Hi, and welcome to this short clip looking at an interesting level question. I love the name raspberry ketone, so I thought I'd leave it on there. I'm assuming obviously the raspberry ketone molecule is what's responsible for raspberry flavouring. I don't know, it's just a great name, I like it a lot. So let's get started. It tells you the structures of the raspberry ketone molecule and cyclohexanol. And it's quite interesting how they're asking about this. There's lots of functional group things going on here, but they specifically are interested in the differences between the structure of the two carbon rings, and the reaction of the hydroxyl group might be different in each one. Now they want examples and at least two equations. So looking at the two compounds, you can see that although you've got an OH group, you've actually got two quite different functional groups. You've got a secondary alcohol on cyclohexanol and a phenol within the raspberry ketone molecule. So we just want to concentrate on the OH groups and not get distracted by the ketone. So you need to ignore the C double bond O because it's not part of the question. So it's quite easy to structure your answer here into the two different compounds and then the two different things that they're asking you about each compound. So you can put bullet points in for your structure of the ring descriptions. It's quite easy. And then for the reactions, you need to think about reaction of a phenol for the raspberry ketone and reaction of secondary alcohols for cyclohexanol. So I'm going to move the page down a bit to make room for the reactions. So just taking two simple examples from A level. The phenol group acts as a weak acid, but the cyclohexanol doesn't. The cyclohexanol, on the other hand, can be oxidized to a ketone, but the phenol group doesn't do this. So let's move the page down a little bit further so we can put the equations in to support what we're doing. So you can put in a reaction like that, but be careful to use sodium hydroxide or hydroxide rather than carbonate as your weak base. So a strong base will react with the phenol, but a weak base won't. So you can see quite clearly that the phenol behaves as a weak acid because it's losing a proton. So cyclohexanol as a secondary alcohol can be oxidized to cyclohexanone, ketone, and water. The source of the oxygen atom is obviously dichromate in the presence of sulfuric acid. And it does no harm to label up the cyclohexanone so the examiner knows that you are aware of the name of that particular compound. So have we included examples? Yes, we have. Have we done two equations? Yep. We've talked about the difference between the two carbon rings and how the reactions of the hydroxyl are different in the two compounds. I think that's us done. So once again, thanks for listening, and until next time, see you soon.